أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Our today's topic is displacement time graph for a body moving in uniform motion and in non-uniform motion. Displacement time graph for a body moving in uniform motion and also next topic non-uniform motion, class 11th. Let us show the displacement time graph of a body moving in a uniform motion first. Let us take it as our time axis. Okay. And it's our displacement axis. This is our origin O. We show time in sample t. Let us show displacement by x. Okay. Where at time t is equal to 0, the displacement is 0. And if the time t is equal to t1, let us show displacement by x1. At time t2, displacement is x2. Graph will be line, straight line. Like this is t1 and this is displacement x1 and this is t2. Let us take like this. Let us take these 2 points here, A and B, on this graph. On this graph, it is a graph of a uniform motion, graph of a displacement time graph of a body moving in a uniform motion. The body moving in a uniform motion covers equal distance in equal intervals of time. It covers equal distance in equal intervals of time. So we can see if this time interval from 0 to t1 and t1 to t2 are equal, then this distance from 0 to x1 and x1 to x2 would be also equal. So the graph may be also equal. The graph may be then a straight line. Graph may be then straight line. Let us show this graph makes an angle theta with this time axis. Also here it would be theta. This line and this line is parallel, so we can see these are two corresponding angles. Let us show it is equal to c. It's equal to c. Okay. Now we know that now velocity is equal to displacement beta time. Velocity is equal to displacement beta time. We know that displacement v is equal to this x2 minus x1. If we take this, let a body move, we can take a time from t1 to t2. Displacement is x1 to x2. Then velocity would be x2 minus x1 divided by t2 minus t1. t2 minus t1. It would be displacement. It would be velocity time. So the slope of this velocity time graph, it may be the slope of this velocity time graph. This v may be it. We can find with this equation the slope of the graph. V is equal to, we can take this equal x2 minus x1, x2 minus x1. We can take this is equal to this BC. And t2 minus t1, we can take this equal to this term. That's equal to t2 minus t2. From this point to this point is t2. If we separate it from a t1, it remains this very portion. Same is the here. From this point to this point it is x2. From this point to this point it is x1. If we separate from x2 minus x1, that means we are separating this distance by this distance. There remains only this distance. We can take it as equal to BC. Same is the case here. from 0 to t2, it is t2 distance. From 0 to t1, it is t1 distance. We get t1 time. It is not a distance, it is a time. So if we subtract t2 this time interval, so this remains from t2, it remains this interval, that is equal to AC. So we can take it equal to AC. So this BC divided by AC, we know from earlier class, in our 10th class, we know that if we are taking this is our right angular triangle, this ACB, then this is theta, and this is a perpendicular, this is hypotenuse, and this is base, and this is perpendicular butter this perpendicular butter this AC perpendicular butter base. So it is a tan of theta. So we can see slope of a slope of a graph in of a body moving in a uniform motion. It is equal to V is equal to tan of theta. Is equal to tan of theta. It is for the body which is moving in a uniform motion. Let us take another body when the body is moving in a non-uniform motion. Okay. Non-uniform motion. Body moving in non-uniform motion. Okay. Say, let us take this our time axis. It is 0. It is time axis, and this is displacement axis. The body is moving in a non-uniform motion like this. Okay. Let us take any time interval t1. Here it will be this x1, and let us take t2. It will be x2. We know that it is A and B. The slope of a graph for a body moving in a non-uniform motion. Okay. We can try straight line. With angle theta here, also angle theta here. Okay. For such, we know that it's a non-uniform motion. Here we find the body travels equal in distance in unequal intervals of time, or unequal distance in equal intervals of time. So the graph of this body is like moving in non-uniform is like this. Here we find it is the velocity. We here find average velocity. Average velocity. Average velocity is a total distance traveled. Total distance traveled divided by total time taken. Total time. Okay. We know that average distance. We can find it V average velocity. That is equal to total distance. We know that is equal to, it is x2 minus this x1 divided by t2 minus t1. Okay. That is also equal to this BC divided by AC. BC divided by AC. V average is also equal to BC divided by AC. It's also equal to this tan of theta. In earlier case, there was V was equal to tan theta. Now V average is equal to tan of theta. Thus, the average velocity of a body having non-uniform motion equals to the slope line joining any 2 points on the displacement diagram. Is equal to the slope joining any 2 points on the displacement diagram. Now, let us take when the time interval delta t is decreased. For example, we know that when we decrease this time interval, this is our change of time from t1 to t2. If we decrease this time interval, let us take the delta t. This time interval is decreased to 0. Then this t1, t2 become closer and closer to this t1. Also, then this point B comes very close to this point A. It comes very close to point A. Then what would happen? Thus the instant as a result of this, the line AB reduce. As a result of this, the line AB reduced. It comes very close to point A. Therefore, the instantaneous velocity of the body equals to the slope of the tangent. Equals to the slope of the tangent at point A. This instantaneous velocity becomes equal to the slope of the this tangent at point